Welcome back to Sleepy Science Facts, where we drift through the wonders of the universe one calm breath at a time. Tonight, we're gliding gently through our solar system, a peaceful neighborhood of planets, moons, and cosmic leftovers quietly orbiting our warm, glowing sun. In this relaxing journey, you'll learn how the solar system formed, what makes each planet unique, and a few soothing secrets hidden in the space between them. So get comfortable, let your thoughts slow down, and enjoy the cosmic calm. Make sure to like, subscribe, and hit the bell for more sleepy science facts. And remember, read the first command for support. The universe is a vast, silent ocean of darkness, a canvas of endless stars stretching beyond imagination. Yet within this immensity, a small, luminous sphere ignites life, motion, and wonder. That sphere is our sun, the heart of a cosmic neighborhood we call the solar system. Around it, worlds of fire, rock, ice, and gas dance in intricate patterns, bound by gravity and the silent rhythm of time. Some of these worlds are familiar, glowing in the sky, shaping the tides, seasons, and life itself. Others lurk in the shadows, icy and distant, hiding secrets billions of years old. To gaze upon the solar system is to gaze upon history itself, to witness the birth of planets from swirling clouds of gas and dust, the violent collisions that sculpted moons and asteroids, the storms and magnetic fields that rage across worlds, and the slow, eternal dance of orbiting bodies that has continued for eons. Every comet streaking across the night sky, every meteorite that crashes upon the Earth, every subtle glimmer of distant dwarf planets like Pluto is a message from the past, a reminder that our planet is part of something infinitely larger, more ancient, and profoundly interconnected. To explore the solar system is to confront the beauty, danger, and majesty of the universe, and to realize that our existence is intertwined with forces that began long before life ever emerged and will continue long after we are gone. It is a story written in light and shadow, in rock and ice, in fire and plasma, a story that stretches across billions of kilometers and billions of years, and one that we are only just beginning to understand. Mercury, the innermost planet of our solar system, is a world forged in extremes, a tiny globe scoured by the sun's unrelenting heat and scarred by billions of years of cosmic bombardment. It is the smallest of the 8 planets, just slightly larger than Earth's moon, yet its diminutive size belies the complexity and resilience of a planet that has endured conditions unlike any other. The proximity to the sun defines everything about Mercury. Its days are blistering, reaching temperatures of over 430 degrees Celsius. Yet when night falls, the absence of an atmosphere capable of retaining heat allows the mercury-rich surface to plunge to minus 180 degrees. These extremes, unimaginable to human experience, shape the rhythms of the planet, its landscapes, and even the particles that float near its surface, as Mercury moves swiftly along its orbital path, completing a full revolution around the sun in just 88 Earth days. The day-night cycle, unlike that of any other planet, is almost surreal. A single rotation on its axis takes 59 Earth days, meaning that a day on Mercury is longer than its year, creating a strange pattern of illumination and shadow, where the sun rises, sets, and rises again with a deliberate, stately pace, casting long, dramatic shadows across cratered plains. The surface of Mercury is a testimony to the violent history of the early solar system. From the heavily cratered highlands to the smooth plains shaped by ancient volcanic activity, the planet's face bears the scars of relentless bombardment. Enormous impact basins, like the Calorus Basin, stretch for over 1,500 kilometers, created by collisions so intense they fractured the crust and sent ripples across the planet's surface, reshaping the landscape in their wake. Between these craters lie vast plains of solidified lava, evidence of a time when Mercury was geologically active, its interior molten and restless, spilling forth through fractures and fissures to reshape the surface over eons. The scarps, immense cliffs rising up to a kilometer high and stretching for hundreds of kilometers, twist and fold the crust, revealing the slow contraction of the planet as its interior cooled, a silent record of Mercury's deep and enduring history. Beneath its scorched and battered exterior, Mercury conceals a dense, iron-rich core, occupying a larger fraction of the planet's volume than that of any other planet in the solar system. This core is partially molten, generating a weak but measurable magnetic field, a remarkable feature for a small, airless planet. The presence of this magnetic field suggests a history of internal dynamism and challenges our understanding of planetary formation and evolution, showing that even a tiny world can harbor unexpected complexity beneath a seemingly barren surface. Observations from spacecraft like Messenger, which orbited Mercury for several years, have revealed volatile elements in the crust and mysterious hollows on the surface, bright patches of terrain that appear to be slowly evaporating under the sun's intense radiation, hinting at processes that are ongoing even today. Mercury's position near the sun also subjects it to a constant bombardment of solar wind, a stream of charged particles that interacts with its magnetic field and surface, sculpting a tenuous exosphere made up of atoms knocked from the crust and blasted into space. Despite its lack of atmosphere, Mercury is not inert. It breathes in a subtle, silent way, responding to the forces that surround it and connecting the planet to the vast magnetic and gravitational networks of the solar system. Its rapid orbit, extreme temperatures, heavily cratered surface, and mysterious exosphere combine to create a world that is harsh, enigmatic, and utterly compelling. A fiery messenger that speaks of the forces that shaped the inner planets and of the fragile balance that allows planets like Earth to exist. To study Mercury is to witness the raw power of the sun, the violence of the early solar system, and the resilience of a small world that has survived billions of years of cosmic storms. It is a place of extremes, a place where fire and ice coexist in the most unforgiving conditions imaginable, where each crater and scar tells a story of collisions, survival, and transformation. Mercury is more than a planet. It is a window into the origins of the solar system, a reminder of the forces that sculpt worlds, and a silent testament to the enduring, dynamic nature of planets even in the face of relentless solar fury. As we leave Mercury behind, hurtling outward toward the shrouded, cloud-covered world of Venus, we carry with us the lessons of resilience, extremity, and the extraordinary beauty hidden within even the smallest of planets. Venus, often called Earth's twin, is a planet of contrasts. a world that seems familiar in size and composition, yet utterly alien in every other way. As we approach it from space, the thick golden clouds that shroud its surface glint in the sunlight, hiding the fury that rages below. These clouds are composed primarily of sulfuric acid droplets, suspended in a dense, opaque atmosphere that traps heat with a greenhouse effect, so extreme that surface temperatures soar beyond 460 degrees Celsius, hotter than the surface of Mercury, despite Venus being nearly twice as far from the Sun. The atmosphere is suffocating, composed largely of carbon dioxide, with clouds that swirl in perpetual motion, driven by super-rotating winds that circle the planet at speeds over 350 kilometers per hour, moving far faster than the planet itself rotates. On Venus, a single day, the time it takes the planet to rotate once on its axis, lasts 243 Earth days, longer than its year of 225 Earth days, creating a surreal rhythm of sunlight and shadow unlike anything we know on Earth. Beneath the thick cloud cover lies a volcanic and rugged surface, revealed through radar mapping by spacecraft like Magellan. Vast plains of basaltic lava stretch for thousands of kilometers, punctuated by enormous shield volcanoes, some towering over 8 kilometers high, suggesting that Venus may still be volcanically active. Large, circular impact craters mark its surface, though far fewer than Mercury's, indicating that much of the crust has been resurfaced by volcanic flows in the planet's tumultuous past. The surface pressure is immense, over 90 times that of Earth at sea level, a crushing weight that would obliterate any unprotected human or spacecraft within moments. It is a world both harsh and beautiful, a landscape of extreme energy sculpted by fire and chemistry, yet hidden beneath an impenetrable golden veil. Venus is also a world of mysteries. Radar studies have revealed tesserae, regions of highly deformed terrain resembling folded and faulted continental crust, reminiscent of mountain ranges on Earth. These formations suggest tectonic activity, though Venus lacks the familiar plate tectonics we know on Earth. The question of whether Venus harbors volcanic activity today remains tantalizing, with hot spots detected from orbit hinting that the planet may still breathe fire and sulfur in silent eruptions beneath the clouds. Its dense atmosphere circulates heat so efficiently that the temperature is nearly uniform across the globe, erasing any hint of day-night variation, a testament to the extraordinary power of the greenhouse effect and a stark warning about climate extremes. The dense shroud of clouds also conceals Venus' complex interaction with the Sun. Solar radiation interacts with the upper atmosphere to create a subtle, faint glow in ultraviolet light, revealing wave patterns, streaks, and eddies in motion, hinting at the dynamic energy cycling within the planet's air. Lightning flashes have been observed, suggesting the presence of electrical storms in the atmosphere, a planet-wide dance of plasma and charged particles invisible to the human eye, yet immense in scale. Venus rotates in a retrograde direction, spinning slowly backward relative to most planets, a quirk likely caused by a massive collision early in its history. This backward spin, combined with its dense atmosphere, produces strange patterns in atmospheric circulation, making Venus one of the most enigmatic worlds in the solar system. Studying Venus is more than an exercise in curiosity. It is a mirror reflecting possible futures for Earth and revealing the extremes of planetary evolution. The runaway greenhouse effect that transformed Venus into a fiery hell illustrates the fragile balance of atmospheric chemistry and solar energy, a reminder that even Earth-sized planets can become uninhabitable under the wrong conditions. Missions such as the European Space Agency's Venus Express and upcoming projects aim to explore the surface and atmosphere in greater detail, probing for signs of past oceans, volcanic activity, and chemical processes that might hint at whether Venus ever harbored conditions suitable for life. To witness Venus is to confront the alien beauty of a world both familiar and deadly. Its clouds glow with golden light, its surface seethes beneath an atmosphere of poison, and its winds race in relentless fury. Venus is a testament to the extremes of planetary existence, a shrouded inferno that challenges our imagination, teaches us the forces of climate and chemistry, and reminds us that even the closest planet to Earth can be utterly inhospitable. As we depart from its blazing clouds and look outward, we prepare to journey to Earth itself, the vibrant, life-giving jewel orbiting the sun, to see how this delicate balance has allowed life to flourish in a universe of extremes. Earth, the third rock from the sun, is a world unlike any other in our solar system, a planet alive with color, motion, and life. From space, it appears as a fragile blue sphere, draped in swirling clouds and veiled in an atmosphere of delicate gases, spinning gracefully in the sun's warmth. Beneath its thin veil of air lies a planet of staggering diversity, oceans deep and teeming, continents of rock and soil, mountains that pierce the skies, deserts that stretch endlessly, and polar regions of ice that glitter like crystal. Earth is a planet in motion. Its crust shifts with tectonic force, mountains rise and erode, rivers carve valleys, glaciers creep slowly yet inexorably, and the oceans surge with tides, currents, and storms. It is a world of contrasts, where fire and ice, wind and water, life and death exist in a delicate balance, all sustained by a magnetic field that shields its surface and a gravity that holds the oceans, atmosphere, and life itself in harmony. The atmosphere, a thin, life-sustaining layer of nitrogen, oxygen, and trace gases, is one of Earth's defining features. It regulates temperature, drives weather, and protects the planet from harmful solar radiation. Clouds, winds, and precipitation are the visible manifestations of energy flowing through the planet, cycling water and heat between surface, sky, and ocean. Hurricanes and typhoons, massive storms born from the interplay of sunlight and ocean heat, demonstrate the planet's power, while gentle rains nourish forests, rivers, and ecosystems. The atmosphere is a living, dynamic system, shaped over billions of years by volcanic activity, the emergence of life, and interactions with the sun, maintaining conditions that allow life to flourish. Earth's surface tells a story written in rock, water, and time. Volcanic plains and lava flows, like those in Hawaii and Iceland, reveal the fiery forces that birthed the continents. Mountains, formed from tectonic collisions, rise majestically as evidence of the relentless pressures within Earth's interior. Rivers and glaciers carve landscapes over millennia, while deserts and plains hold records of climatic shifts and ancient oceans. Beneath the surface, the planet's molten core generates a magnetic field, shielding life from harmful solar winds and guiding compasses for civilizations across millennia. Earth is not static. It is a world of constant change, where continents drift, mountains crumble, and oceans shape and reshape the planet in a slow, unstoppable dance of creation and destruction. Life on Earth is perhaps its most extraordinary feature. From microscopic organisms in the soil and oceans to towering forests and sprawling savannas, life has colonized nearly every corner of the planet. The oceans teem with plankton, fish, and whales, the skies with birds and insects, the land with mammals, reptiles, and humans. Earth's ecosystems are intricate networks, interconnected and fragile, sustained by energy from the sun and cycles of water, carbon, and nutrients. Life has also shaped the planet. Oxygen released by photosynthetic organisms transformed the atmosphere, creating a protective shield and enabling more complex organisms to thrive. Earth is a planet where geology and biology intertwine, where the forces of rock, water, and air are inseparable from the evolution of life itself. Earth also interacts with the broader solar system in ways that have profound consequences. The moon, our constant companion, stabilizes the planet's tilt, moderates tides, and illuminates the night sky, influencing both natural cycles and human culture. Meteors and comets, remnants of the solar system's formation, occasionally strike Earth, delivering water, organic compounds, and minerals, while reminding us of the constant flow of matter and energy throughout space. The sun drives the seasons, weather, and climate, shaping ecosystems and life cycles across the globe. Earth is not isolated. It is part of an intricate cosmic system, where even distant planets and asteroids exert subtle influences, and where the balance between orbit, rotation, and energy creates conditions uniquely suited for life. Studying Earth allows us to understand not only our home planet, but also the principles that govern other worlds. By observing volcanic eruptions, atmospheric circulation, and ocean currents, scientists can make sense of similar processes on Venus, Mars, and beyond. Earth is a reference, a laboratory, and a living example of how planets can harbor life, maintain stability, and endure for billions of years. From space, it is breathtakingly beautiful, a vibrant jewel in the blackness of space. Yet beneath its beauty lies a complex and sometimes dangerous interplay of forces that reminds us of the fragility and resilience of life. Earth is more than a planet. It is a story of energy, matter, and life intertwined over billions of years. A delicate balance sustained by natural forces and a living record of the solar system's history. To gaze upon Earth from the vantage of space is to witness a rare miracle in the cosmos, a planet alive, ever-changing, and intricately connected to the sun and its neighbors. It is a testament to the extraordinary conditions that allow life to thrive, the constant interplay of physical and biological processes, and the delicate balance of energy and matter that sustains this living world. Earth is at once familiar and wondrous, our home and our teacher, revealing the beauty, complexity, and fragility of planets in a universe vast beyond comprehension. Mars, the fourth planet from the Sun, is a world of contrasts, a rusty desert of red rock and ice, ancient riverbeds, and colossal volcanoes that testify to a violent and dynamic past. Its reddish hue, caused by iron oxide coating its surface, has captured human imagination for centuries, inspiring myths, speculation, and now scientific curiosity. From orbit, Mars appears calm, dotted with polar ice caps and layered terrain, but its surface tells a story of ancient floods, volcanic outbursts, and tectonic shifts. Towering above the plains is Olympus Mons, the tallest volcano in the solar system, a shield of basalt rising over 21 kilometers high, nearly 3 times the height of Mount Everest, a monument to the planet's geologic power. Nearby, the Valles Marineris Canyon system stretches over 4,000 kilometers, a vast scar deeper than the Grand Canyon, carved over eons by tectonic forces and possibly water erosion, revealing the restless nature of Mars, crust, and the history of a planet once shaped by flowing liquid. Beneath its thin, carbon dioxide-dominated atmosphere, Mars holds traces of a watery past. Ancient river valleys, lake beds, and mineral deposits suggest that billions of years ago, the planet was warmer and wetter, with flowing rivers, lakes, and perhaps oceans that could have supported microbial life. The polar ice caps, composed of water and dry ice, grow and shrink with the seasons, hinting at cycles of climate change that have influenced the planet for millennia. Dust storms, some of them planet-wide, sweep across the landscape with relentless intensity, shaping dunes, eroding rock, and demonstrating the power of wind in a seemingly lifeless world. Mars is a place where time is recorded in rock layers and surface features, where every crater and canyon tells a story of cosmic impacts, volcanic eruptions, and the slow, inexorable forces of erosion. The search for life on Mars has driven decades of exploration. Robotic missions, from the Viking landers to the rovers Spirit, Opportunity, Curiosity, and Perseverance, have explored the Martian surface, revealing ancient clay deposits, sedimentary layers, and organic molecules, all evidence that the planet may once have had the conditions necessary for life. The discovery of recurring slope lineae, dark streaks on some slopes, hints at the presence of briny water flows even in modern times, raising tantalizing questions about the potential for microbial life surviving in subsurface habitats. Mars is both a window into the past and a mirror for the future, showing how a planet similar to Earth in size and composition could evolve so differently under varying atmospheric and solar conditions. Mars, moons, Phobos and Deimos, small and irregularly shaped, add to the planet's mystery. Likely captured asteroids from the nearby asteroid belt, they orbit close to Mars in rapid, irregular patterns, slowly spiraling inward due to tidal forces. These moons serve as reminders of the dynamic environment of the inner solar system, where planets and smaller bodies constantly interact, collide, and influence each other's evolution. Phobos, with its network of grooves and craters, appears as a battered relic, while Deimos, smoother and more distant, drifts silently, both guardians and witnesses to the planet's long history. The Martian climate is harsh and unforgiving. Temperatures fluctuate widely, often plunging to minus 125 degrees Celsius at the poles in winter, while daytime highs near the equator barely rise above zero. The thin atmosphere offers little protection from cosmic radiation and meteoric impacts, making survival on the surface a tremendous challenge. Yet Mars continues to beckon humanity, inspiring robotic exploration, orbital satellites, and dreams of human settlement. Scientists study its geology, atmosphere, and potential water reservoirs to understand how life could endure, how resources might be utilized, and how the planet's past conditions can inform our understanding of planetary habitability. Mars is a world of endurance, of ancient rivers frozen in time, of volcanic giants towering over desolate plains, of polar ice caps and dust storms that demonstrate the power of nature unbridled by human interference. It is a planet that teaches resilience, adaptation, and curiosity, offering both warnings and hope for the future of Earth. To explore Mars is to explore the possibilities of life beyond our home planet, to confront the challenges of a world harsh yet full of scientific treasures, and to appreciate the delicate balance that allows planets like Earth to sustain life. The red planet stands as a monument to the solar system's capacity for transformation, for extremes of climate and geology, and for the enduring allure of discovery that drives humanity to reach ever outward into the cosmic frontier. Jupiter, the fifth planet from the Sun, is a world of superlatives, the colossal king of the solar system, a planet so massive that it dwarfs all others combined, a swirling sphere of gas, storms, and magnetic fury. From space, Jupiter appears as a banded jewel of colors, its atmosphere striped with shades of white, orange, brown, and red, each band marking turbulent zones of wind and pressure, moving at incredible speeds in a perpetual dance around the planet. The most famous of these features, the Great Red Spot, is a storm larger than Earth itself, a raging tempest that has persisted for centuries, churning with winds that exceed 400 kilometers per hour, a visible testament to the immense energy contained within Jupiter's atmosphere. Unlike the rocky worlds of the inner solar system, Jupiter is composed mostly of hydrogen and helium, a planet without a solid surface, where gases gradually compress into a dense, metallic hydrogen core that generates one of the strongest magnetic fields in the solar system. A field so vast that it stretches millions of kilometers, capturing charged particles and creating intense radiation belts around the planet. Jupiter's sheer size and gravity make it a central figure in the architecture of the solar system. Its immense pull influences the orbits of countless objects, from asteroids in the asteroid belt to icy bodies in the Kuiper belt and beyond. It acts as both protector and predator, deflecting or capturing comets and asteroids that might otherwise threaten the inner planets, yet occasionally sending debris hurtling toward the solar system's inner sanctum. Its gravity sculpts the paths of Trojan asteroids, swarms of ancient remnants that share Jupiter's orbit, offering clues to the primordial conditions of the solar system. Jupiter is not merely a planet. It is a cosmic anchor, a force shaping the motion of worlds over billions of years. The planet's moons are equally remarkable, a miniature solar system in themselves. The four largest, the Galilean moons Io, Europa, Ganymede, and Callisto, are worlds of astonishing diversity and intrigue. Io, closest to Jupiter, is a volcanic powerhouse, the most geologically active body in the solar system, where lava lakes and towering plumes of sulfur erupt endlessly, powered by tidal heating from Jupiter's immense gravity. Europa, with its icy shell, conceals a vast subsurface ocean that may harbor the conditions for life, a hidden world of water beneath a crust of frozen ice. Ganymede, the largest moon in the solar system, possesses its own magnetic field, and its icy surface is marked with grooves and ridges, revealing a complex history of tectonics and potential oceanic layers beneath. Callisto, heavily cratered and ancient, preserves the scars of billions of years of impacts, a witness to the early chaos of the solar system. Together, these moons exemplify the diversity of planetary bodies, demonstrating that even around a gas giant, worlds can be dynamic, unique, and potentially habitable. Jupiter's atmosphere itself is a laboratory of extremes. The upper clouds are composed of ammonia ice, while deeper layers contain ammonium hydrosulfide and water clouds, creating complex chemical interactions that produce its striking coloration. Gigantic cyclones, vortices, and turbulence ripple through the atmosphere, feeding off the planet's rapid rotation, which completes a full spin in just under 10 hours despite the planet's immense size. Lightning storms flash within these cloud layers, releasing energy comparable to that of millions of lightning strikes on Earth, while auroras at the poles dance across the magnetic field, fueled by charged particles spiraling along the magnetosphere. Jupiter is a world in perpetual motion, where the forces of physics and chemistry operate on scales far beyond human experience. A stormy giant whose energy and power are palpable even from the distance of billions of kilometers. Jupiter also serves as a living record of the solar system's formation. Its composition, rich in primordial hydrogen and helium, and its numerous moons, preserve evidence of the processes that created planets and shaped their orbits. By studying Jupiter, scientists gain insight into planetary accretion, migration, and the role of giant planets in protecting or endangering inner rocky worlds. Missions such as Galileo, Juno, and the forthcoming Europa Clipper explore these mysteries, mapping the magnetic field, probing the atmosphere, and investigating the hidden oceans of moons that may contain the ingredients for life. Jupiter is not only a planet of awe-inspiring size and beauty, it is a key to understanding the history and dynamics of the solar system itself. To witness, Jupiter is to stand in the presence of power on an unimaginable scale, a planet that embodies extremes in gravity, energy, and magnetism. It is a world without solid ground, yet solid in its influence. A stormy, gaseous giant whose presence dominates the planetary family, shaping the paths, climates, and histories of neighboring worlds. Jupiter is a king in every sense, immense, commanding, and full of secrets. A reminder of the forces that sculpt the cosmos, the beauty and terror of planetary dynamics, and the delicate balance that allows worlds like Earth to exist in the shadow of giants. As we leave Jupiter behind, hurtling toward the frozen realms of Saturn, we carry with us the lessons of scale, motion, and energy, ready to explore the next majestic titan in our solar system. Saturn, the sixth planet from the Sun, is a world of elegance and majesty, a giant adorned with rings that have captivated human imagination for centuries. Unlike the rocky planets of the inner solar system, Saturn is a gas giant, composed primarily of hydrogen and helium, its atmosphere a canvas of pale yellows, muted golds, and soft browns, rippling with clouds, storms, and jet streams that circle the planet with relentless precision. Its low density, so light that, if placed in a vast enough ocean, it would float, belies the immense scale of its presence. Saturn's rapid rotation, completing a full turn in just over 10 hours, flattens its poles and bulges at the equator, creating an oblate, pancake-like shape that is as distinctive as it is breathtaking. The planet is a world in motion, alive with storms, vortices, and subtle winds that trace patterns across its hazy atmosphere, and each feature speaks to the interplay of gravity, pressure, and chemistry on a scale beyond ordinary human experience. The defining feature of Saturn, however, is undoubtedly its rings. From afar, they shimmer like celestial jewelry, spanning hundreds of thousands of kilometers yet astonishingly thin, sometimes no more than a few hundred meters in depth. Composed of billions of ice and rock particles ranging from microscopic grains to massive boulders, the rings reflect sunlight, creating a luminous halo that encircles the planet in a spectacle of cosmic artistry. These rings are not merely decorative. They are dynamic, constantly shifting under the influence of Saturn's gravity and the gravitational tugs of its numerous moons. Gaps, waves, and braids ripple through the rings, evidence of resonances with moons and the ongoing dance of particles in orbit. The rings are a living laboratory, a reminder of the delicate balance that governs planetary systems and the beauty that arises from the interplay of physics and motion. Saturn's moons are as diverse and fascinating as the rings themselves. Titan, the largest, is a world larger than Mercury, with a thick nitrogen-rich atmosphere and surface lakes of liquid methane and ethane, a hydrological cycle of alien rivers and rain that mirrors, in strange ways, the water cycle on Earth. Beneath its hazy orange skies, Titan may harbor oceans of water beneath its icy crust, hinting at the potential for life in hidden environments. Enceladus, a smaller moon, is a frozen world that belies its activity. Geysers of water and ice erupt from its south polar region, shooting plumes into space that form part of Saturn's E-ring, and suggesting the presence of a subsurface ocean heated by tidal forces from Saturn's gravity. Other moons, such as Rhea, Dione, Iapetus, and Mimas, display craters, ridges, and unique geological features, each a testament to the complex histories of impact, tidal heating, and internal evolution. Saturn's moons, like the rings, are intricately linked to the planet, their motions and interactions revealing the delicate forces shaping a giant world. The planet's interior is a mystery, hidden beneath thick layers of hydrogen and helium, gradually compressing into metallic hydrogen under immense pressure. This metallic layer generates Saturn's magnetic field, strong enough to create auroras at its poles, where charged particles spiral along invisible lines of force, illuminating the atmosphere with shimmering light. Storms rage in the upper atmosphere, from massive cyclones at the poles to the long-lived hexagon at Saturn's North Pole, a geometric wonder that has persisted for decades, rotating with the planet like a perfectly balanced celestial gear. The dynamics of Saturn's weather, its internal heat, and its magnetic field offer insights into the processes that govern gas giants and the formation of planetary systems. And missions like Cassini have provided unprecedented views of these wonders, revealing complexity, beauty, and power beyond imagination. Saturn also serves as a historical record of the solar system. Its rings and moons preserve the remnants of the primordial disk from which the planets formed, capturing the interplay of ice, rock, and gravity over billions of years. By studying Saturn, scientists trace the evolution of giant planets, their interactions with smaller worlds, and the forces that shape orbits, tides, and magnetic environments. The planet is both a window into the past and a beacon for the future, offering clues about the potential for life on moons like Titan and Enceladus, the processes that govern planetary atmospheres, and the delicate balance required to sustain complex systems over cosmic timescales. To behold Saturn is to witness elegance and power intertwined. Its luminous rings, swirling clouds, and diverse moons create a tableau of grandeur unmatched in the solar system. It is a planet of motion, energy, and mystery, a testament to the beauty of gravity and the artistry of natural forces. Saturn reminds us that the solar system is not just a collection of planets, but a living, dynamic system where forces of unimaginable scale sculpt worlds, where moons and rings tell stories of time and motion, and where even the largest planets are shaped by delicate balances and cosmic rhythms. As we leave Saturn's golden rings behind and journey outward toward Uranus, we prepare to explore a planet both familiar and alien, tilted on its side, shrouded in pale blue, a world of ice and secrets awaiting discovery. Uranus, the seventh planet from the Sun, is a world of peculiarity and extremes, an ice giant turned on its side, rotating in a manner that defies the conventions of the solar system. Unlike Jupiter and Saturn, composed mostly of hydrogen and helium, Uranus is rich in ices, water, ammonia, and methane, which give it a pale blue hue, tinted by the methane that absorbs red light and scatters the blue. From afar, Uranus seems calm, featureless even, a soft, icy orb drifting silently in the vast darkness beyond Saturn. Yet beneath this serene exterior lies a planet of dramatic dynamics, hidden weather, and complex systems shaped by a history of collisions and cosmic evolution. Its axial tilt is extreme, about 98 degrees, meaning it essentially rolls along its orbital path like a spinning top, with its poles alternating between long, sunlit summers and long, frozen winters lasting decades. This tilt is thought to be the result of a massive impact early in Uranus history, a collision so violent that it knocked the planet onto its side and altered the nature of its seasons forever. Uranus' atmosphere is a layered, dynamic environment composed primarily of hydrogen and helium, with traces of methane, water, and ammonia. Although its outer clouds appear pale and uniform, careful observation reveals bands, clouds, and storms shaped by winds reaching up to 900 kilometers per hour, faster than the speed of sound on Earth. These winds flow in the direction of rotation and interact with the planet's extreme tilt to produce unique seasonal patterns, where one hemisphere may be bathed in sunlight for decades, while the other plunges into near total darkness. Uranus is an alien world, both subtle and extreme, a place where climate and energy operate on scales and rhythms unimaginable to human experience, and where the visible tranquility belies the turbulent forces beneath. The moons of Uranus are equally fascinating, a diverse collection of worlds that orbit in near-perfect alignment with the planet's tilted equator. The 5 largest moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are icy landscapes scarred with impact craters, deep canyons, ridges, and evidence of internal heating. Miranda, in particular, is a geological wonder, its surface a patchwork of cliffs, ridges, and strange coronae that suggest violent tectonic activity and resurfacing events in its distant past. These moons hold the keys to understanding Uranus, history, revealing how ice, rock, and tidal forces interact to shape planetary satellites in extreme environments. Smaller moons and ringlets of ice and dust form delicate rings, faint but distinct, whispering secrets of collisions, gravitational interactions, and the remnants of primordial material from the planet's formation. Uranus' interior is a story of compressed ices and rock, with a relatively small core surrounded by a vast mantle of water, ammonia, and methane ices. Under extreme pressures and temperatures, these compounds may form exotic superionic states, conducting electricity in ways that create magnetic fields distinct from the Earth, like dipoles seen on other planets. Uranus' magnetic field is tilted and offset from its rotation axis, producing complex interactions with the solar wind and generating auroras that glow in ultraviolet light. These features reveal the unusual physics of ice giants, where internal composition, rotation, and energy combine to create a planetary environment that is both alien and scientifically invaluable. Exploring Uranus offers insight into the broader solar system and the formation of planets beyond. Its ice-rich composition provides clues about the distribution of volatile materials in the outer solar system, while its moons and rings reveal the subtle balance between gravity, tides, and orbital dynamics. The planet's extreme tilt and unusual magnetic field challenge our understanding of planetary physics, offering a laboratory for studying phenomena that cannot be replicated on Earth. Uranus reminds us that planetary systems are diverse and unpredictable, that collisions and cosmic forces can create worlds of unimaginable strangeness, and that even the seemingly calm and pale planets conceal dramatic histories and hidden energy. To observe Uranus is to encounter quiet grandeur, a pale blue world rolling along its orbital path, mysterious and elegant, holding secrets of ice, rock, and primordial collisions. It is a planet that teaches us the power of angles, rotations, and hidden energy, where the frozen surface is only the beginning of the story, and where moons and rings add complexity and beauty to the narrative. Uranus stands as a reminder that the solar system is not uniform. It is a tapestry of worlds, each with its own character, history, and mysteries, and that exploration reveals both the familiar and the extraordinary in ways that challenge our understanding and inspire wonder. As we leave Uranus behind and venture further into the outer reaches, we approach Neptune, the distant, deep blue sentinel of the solar system, whose storms, winds, and icy secrets await discovery in the shadowy frontier of the cosmic ocean. Neptune, the 8th planet from the Sun, is a world of wind, storms, and icy mysteries, the outermost giant of our solar system, cloaked in deep azure hues that shimmer with ethereal beauty. From afar, it appears serene, a distant jewel of vivid blue and soft white. Yet up close, Neptune is a dynamic and tempestuous planet, a realm where the atmosphere roils with storms, high-speed winds, and giant vortices. Its striking blue color comes from methane in the atmosphere, which absorbs red light and scatters the blue, enhanced by other unknown compounds that give Neptune its unique luminous hue. The planet is a gas giant, composed mostly of hydrogen, helium, and icy volatiles, with no solid surface, and its internal heat drives the planet's astonishing meteorology, despite its great distance from the Sun. Neptune completes a full rotation in about 16 hours, whipping its atmosphere into rapid bands, creating storms of unimaginable intensity, and maintaining its magnetosphere that interacts with the solar wind, producing auroras more powerful than those on Earth. The most famous of Neptune's atmospheric phenomena is the Great Dark Spot, a storm comparable in size to Earth itself, observed by Voyager 2 during its historic flyby in 1989. This storm, a massive vortex swirling through the upper atmosphere, demonstrates the immense energy contained in Neptune's winds, which reach speeds of over 2,100 kilometers per hour, the fastest in the solar system. Smaller storms, white cloud streaks, and transient vortex systems appear and vanish over months and years, a constant reminder that Neptune's atmosphere is alive, turbulent, and ever-changing. The interplay of heat from the interior and solar radiation at the outer layers generates convection, cloud formation, and violent weather patterns, creating a planet that is dynamic despite its remoteness and faint sunlight. Neptune's moons are a testament to the diversity and complexity of planetary satellites. Triton, its largest moon, is unique among large moons in the solar system because it orbits Neptune in a retrograde direction, suggesting that it was captured from the Kuiper belt rather than forming alongside Neptune. Triton is an icy world of geysers and active geology, with nitrogen plumes rising from the surface, hinting at a subsurface layer of warmth and energy that defies expectations for a moon so far from the Sun. Smaller moons, such as Proteus, Nereid, and Larissa, follow irregular paths, scarred by collisions, and offer further insight into the formation and evolution of Neptune's satellite system. These moons, combined with faint rings of dust and ice, create a miniature, dynamic ecosystem around the planet, revealing the subtle gravitational interactions and ongoing processes shaping the outer solar system. Beneath the cloud tops, Neptune's interior is a layered world of ice, rock, and gas. The planet is classified as an ice giant, with a mantle composed of water, ammonia, and methane ices over a rocky core. Pressures and temperatures increase dramatically toward the center, potentially creating exotic forms of ice and metallic compounds that conduct electricity, contributing to Neptune's unusual magnetic field, which is both tilted and offset from its rotation axis. The magnetic environment interacts with the solar wind to produce auroras and radiation belts, forming a protective cocoon around the planet and adding complexity to the already dynamic system. Neptune is a world where extreme physics governs every aspect of its interior and exterior, a laboratory for understanding the forces that shape ice giants and the behavior of matter under unimaginable conditions. Exploring Neptune provides insight into planetary formation, atmospheric dynamics, and the evolution of the outer solar system. Its distance from the Sun preserves clues to early solar system history, while its active atmosphere and moons reveal that even the cold, distant planets are alive with energy. The mysteries of Neptune's storms, winds, and deep blue coloration continue to challenge scientists, while missions like Voyager 2, Hubble observations, and future planned spacecraft offer glimpses into the workings of this remote world. Neptune serves as a reminder that the solar system is not confined to the warmth of the inner planets. Even in the darkness and cold of the outer reaches, complex and powerful processes continue, shaping planets and moons alike. To behold Neptune is to witness the majesty of the far reaches of the solar system, a deep blue sentinel spinning in the shadows, alive with storms, winds, and icy moons. It is a world that embodies extremes, temperature, wind speed, and distance from the Sun, yet also elegance, beauty, and complexity. Neptune teaches us that planets are more than mere spheres of gas and rock. They are dynamic systems, each with unique characteristics and interactions, influenced by gravity, rotation, heat, and chemistry. As we leave Neptune behind, we turn our gaze toward the outer edges of the solar system, where icy bodies, comets, and dwarf planets like Pluto await, revealing the boundaries of our planetary neighborhood and the ongoing story of creation, evolution, and cosmic wonder in the distant frontier. Beyond Neptune lies the remote and enigmatic region of the solar system known as the Kuiper Belt, home to icy worlds, dwarf planets, and countless small bodies that orbit the Sun in frozen solitude. Among these, Pluto shines brightest in our imagination, a symbol of exploration and the vastness of space. Once classified as the 9th planet, Pluto now holds the distinguished status of a dwarf planet, yet it is no less fascinating. Composed of rock and ice, with a diameter of just over 2,300 kilometers, Pluto is smaller than Earth's moon, yet it exhibits remarkable complexity, with mountains, plains, glaciers, and a tenuous nitrogen atmosphere that changes with its seasons. The surface is a patchwork of features, from the vast, heart-shaped Sputnik Planitia, a frozen nitrogen plain, to rugged, icy mountains that soar kilometers into the thin sky, all hinting at geological activity that continues to reshape this distant world. Pluto's atmosphere is a fragile veil of nitrogen, methane, and carbon monoxide, extending hundreds of kilometers above the surface. As it moves along its highly elliptical orbit, the planet's proximity to the Sun causes seasonal changes. During its closest approach, ices sublimate into gas, thickening the atmosphere, while farther from the Sun, gases freeze and fall back to the surface. These subtle cycles of vapor and frost create dynamic weather patterns, with winds that can carve dunes in the nitrogen ice and frost deposits that drift across plains. Despite its small size and frigid environment, Pluto is alive in its own way, a world where geology and climate continue to interact, defying expectations for such a distant and frozen planet. Pluto is accompanied by a family of moons, the largest being Charon, nearly half Pluto's size, creating a binary system that rotates around a shared center of mass. Charon's surface is marked by canyons, ridges, and plains of water ice, evidence of tectonic and possibly cryovolcanic processes. Other moons, Styx, Nix, Kerberos, and Hydra, are smaller and irregular, shaped by ancient collisions and the gravitational forces of their larger siblings. Together, this system demonstrates the diversity and complexity of dwarf planets and provides insight into the processes that govern moon formation, tidal interactions, and orbital dynamics in the outer solar system. Beyond Pluto, the Kuiper Belt stretches outward, populated by icy worlds, comets, and remnants of the primordial solar system. Objects such as Haumea, with its elongated shape and fast rotation, Makemake, with its reflective icy surface, and Eris, larger than Pluto yet more distant, exemplify the diversity and strangeness of these outer worlds. These bodies are frozen archives of the early solar system, preserving information about the formation of planets, the distribution of ice and rock, and the dynamic interactions that sent some objects inward and left others in distant, stable orbits. Studying these dwarf planets and Kuiper Belt objects provides a window into the processes that shaped our planetary neighborhood and hints at the untold stories of countless unseen worlds in the farthest reaches of the sun's influence. Even farther still lies the hypothetical Oort cloud, a vast, spherical shell of icy bodies stretching almost a light year from the sun. Though unseen, this region is thought to be the source of long-period comets that occasionally visit the inner solar system, carrying ancient materials and organic compounds that may have influenced the origins of life on Earth. Pluto and the dwarf planets, as the most accessible members of this distant frontier, offer humanity the first glimpses into this remote, icy wilderness, revealing a solar system far larger, more diverse, and more mysterious than our ancestors ever imagined. Pluto teaches us that size does not determine significance. Though small and distant, it holds clues to planetary evolution, cryovolcanism, and the subtle mechanics of atmospheres and moons in extreme conditions. It reminds us that the edge of the solar system is not empty or lifeless, but a realm where physics, chemistry, and history converge in frozen elegance, a place where the sun's influence wanes yet still shapes worlds in quiet, enduring ways. As we explore Pluto and the dwarf planets, we confront the vastness of the cosmos and our own curiosity, recognizing that the story of the solar system extends beyond the 8 classical planets, into a realm of ice, rock, and mystery that challenges our understanding and expands the horizon of human knowledge. The journey to Pluto and its companions, once a dream and now a reality through missions like New Horizons, brings the distant fringes of the solar system into sharp relief, revealing landscapes both alien and beautiful, frozen worlds sculpted by time and energy. It is here, at the edge of our planetary neighborhood, that the story of the solar system finds its outermost chapters, places of extremes, quiet grandeur, and enduring mysteries, where humanity's gaze stretches ever farther, seeking understanding, wonder, and the infinite possibilities that lie beyond. At the center of our solar system burns a colossal furnace, the Sun, a star of unimaginable power and influence, whose light and heat sustain life on Earth and govern the motions of all planetary bodies around it. The sun is not merely a sphere of glowing gas. It is a complex, dynamic system of plasma, magnetic fields, and nuclear reactions, a living engine that has powered the solar system for 4.6 billion years and will continue to shine for billions more. Composed primarily of hydrogen and helium, the sun converts mass into energy through nuclear fusion in its core, where pressures reach hundreds of billions of atmospheres and temperatures soar to 15 million degrees Celsius. Each second, the sun fuses over 600 million tons of hydrogen into helium, releasing energy in the form of light, heat, and high-energy particles that radiate outward in all directions, bathing the planets, moons, and interplanetary space in warmth and light. The structure of the sun is layered and intricate. Its core, the seat of fusion, is surrounded by the radiative zone, where energy slowly migrates outward over thousands of years, and the convective zone, where rising and falling currents of plasma carry energy to the surface. The photosphere, the sun's visible surface, is a roiling sea of granules, each a convective cell spanning hundreds of kilometers, where heat rises and falls in a constant dance. Above this lies the chromosphere and the corona, tenuous layers of gas that glow with ultraviolet and X-ray light, extending millions of kilometers into space, forming the solar wind that streams outward, interacting with planetary magnetospheres, and shaping the space environment throughout the solar system. Solar flares and coronal mass ejections erupt from these layers, releasing billions of tons of plasma at incredible speeds, reminders of the sun's volatile and energetic nature. The sun's influence extends far beyond its visible light. Its gravitational pull anchors the planets, comets, and asteroids in their orbits, creating a delicate balance that maintains the architecture of the solar system. Its radiation drives planetary atmospheres, weather, and climate, energizing winds, ocean currents, and the hydrological cycle on Earth. Solar activity, including sunspots and magnetic storms, shapes space weather, producing auroras and affecting satellites, communications, and technology on our planet. The sun is simultaneously a giver of life and a reminder of the cosmic forces that operate on scales far beyond human comprehension. Studying the sun is not merely an academic pursuit. It is a window into the workings of all stars. By observing sunspots, flares, and magnetic cycles, scientists understand stellar evolution, the life cycles of stars, and the conditions necessary for planetary habitability. The 11-year solar cycle, marked by the waxing and waning of sunspots and magnetic activity, influences space weather and climate patterns on Earth, demonstrating the intricate link between our star and the worlds it illuminates. Instruments on spacecraft like the Solar and Heliospheric Observatory, SOHO, Parker Solar Probe, and Solar Orbiter have penetrated the sun's outer layers, capturing high-resolution images, magnetic maps, and particle data, revealing a star far more dynamic, violent, and complex than the serene golden disk we perceive from Earth. The sun is also a chronicle of time. Its energy has powered life on Earth for billions of years, driving photosynthesis, climate cycles, and the evolution of ecosystems. It shapes planetary atmospheres, drives chemical reactions, and provides a constant source of energy that maintains habitable conditions. Yet it is not eternal. Over billions of years, It will exhaust its hydrogen fuel, expand into a red giant, engulfing the inner planets and altering the solar system irrevocably, before collapsing into a dense, cooling white dwarf. Understanding the sun, therefore, is to understand both the present and future of our planetary home, the fragility of life, and the cosmic cycles of creation and destruction. To gaze upon the sun, even from a distance, is to witness the heart of the solar system in action, a massive, glowing, energetic sphere whose presence defines the motion, climate, and life of every world around it. It is a star of extremes, immense gravity, searing heat, blinding light, yet also a source of balance, order, and sustenance, a cosmic engine whose influence extends from Mercury to Pluto, from the inner planets to the icy fringes of the Kuiper Belt. The sun teaches us about energy, motion, and time, about creation and destruction, and about the delicate conditions that make planets like Earth habitable. In the story of the solar system, the sun is the protagonist, the constant source of energy and life, whose story intertwines with every planet, moon, asteroid, and comet, and whose presence reminds us that in the vast theater of the cosmos, a single star can shape worlds, histories, and the destiny of life itself. Beyond the planets and moons lies a vast population of smaller objects, asteroids, comets, and meteors, remnants of the primordial material from which the solar system formed. Though often overlooked compared to the grandeur of planets, these small bodies hold vital clues to the history and evolution of the solar system. They are time capsules, preserving ancient material from billions of years ago, before the planets coalesced, carrying chemical signatures, isotopes, and structures that reveal the processes that created our cosmic neighborhood. These objects also serve as reminders of the dynamic and sometimes violent nature of space, capable of striking planets, shaping surfaces, and even influencing the course of life itself. Asteroids, mostly concentrated in the asteroid belt between Mars and Jupiter, are rocky and metallic bodies of varying size, from tiny pebbles to objects hundreds of kilometers across. The largest series is classified as a dwarf planet and exhibits evidence of water ice and cryovolcanic activity, while smaller asteroids like Vesta and Pallas display varied geology, craters, and surface features that record billions of years of collisions and solar radiation exposure. Asteroids are not merely inert rocks. Many are rubble piles, loosely held together by gravity, some spinning rapidly, some tumbling through space in chaotic orbits. They are survivors of a chaotic epoch, fragments of larger worlds destroyed in collisions, and their study provides insight into planetary formation, the distribution of metals, and the conditions in the early solar system. Comets, in contrast, are icy wanderers, often described as dirty snowballs, composed of water, carbon dioxide, ammonia, methane, and dust. Most originate from the Kuiper Belt and Oort cloud, far beyond Neptune, and are occasionally perturbed into the inner solar system by gravitational interactions with planets or other stars. As they approach the sun, the heat sublimates their ices, creating glowing comas and long, often spectacular tails of gas and dust that can stretch millions of kilometers. Comets such as Halley's Comet and Comet NEOWASC remind us of the solar system's dynamism, and of the reservoirs of ancient materials that persist in the cold, dark outskirts. Some scientists believe comets may have delivered water and organic compounds to early Earth, seeding the building blocks for life and linking these distant objects to the story of our own planet's habitability. Meteors, meteoroids, and meteorites represent the intimate connection between these small bodies and planetary surfaces. When a meteoroid enters Earth's atmosphere, friction causes it to burn brightly as a meteor, a fleeting streak of light in the sky, a visible reminder of the ongoing interactions between Earth and the rest of the solar system. Occasionally, fragments survive passage through the atmosphere, reaching the surface as meteorites. These rocks are studied extensively, revealing compositions ranging from stony silicates to iron-nickel alloys, and sometimes containing presolar grains and isotopes that predate the formation of the sun itself. Meteorites provide direct, tangible evidence of cosmic processes, collisions, and chemical evolution, linking our world to the broader cosmos in a way that few other objects can. The small bodies of the solar system are also active participants in its dynamics. Jupiter's gravity, for instance, influences the orbits of many asteroids, creating gaps, resonances, and even sending some careening toward the inner planets. Comets are shaped by solar radiation, tidal forces, and collisions, constantly evolving and leaving behind trails of debris that later become meteor showers on Earth. These interactions are a constant reminder that the solar system is not static. It is a living system of bodies large and small, interacting over billions of years, subject to the forces of gravity, radiation, and chance collisions. Exploration of these small bodies has expanded dramatically in recent decades. Missions such as Dawn, Rosetta, Hayabusa, and OSIRIS-RX have visited asteroids and comets, sampling surfaces, mapping compositions, and even returning materials to Earth for laboratory study. These missions reveal the incredible diversity of these objects, some ancient and unchanged since the solar system's formation, others shaped by collisions, heat, or chemical activity. They illuminate the history of water, organics, and planetary formation, and provide a testbed for understanding the risks and opportunities presented by near-Earth objects. Some of these small bodies could serve as resources for future space exploration, offering water, metals, and building materials for human colonies beyond Earth. Asteroids, comets, and meteors are more than remnants. They are storytellers. Each crater, icy plume, and dust trail is a message from the early solar system, a whisper of the forces that shaped planets and moons, and a record of the ongoing interactions that continue to define space. They remind us of the fragility of life, the potential dangers from cosmic impacts, and the interconnectedness of all bodies orbiting the sun. These small travelers carry the history of billions of years in their mass and composition, linking the distant, frozen reaches of the solar system with the life-rich inner planets, and offering a tangible connection between humanity and the cosmos. To observe these small bodies is to witness the solar system's intricate and ongoing narrative, where massive planets dominate the architecture, but tiny rocks, ice, and dust tell the story of origins, change, and cosmic evolution. They demonstrate that even the smallest objects can have profound significance, influencing planetary history, delivering materials for life, and offering insight into the universe's workings. As we look beyond the planets to these distant, often overlooked wanderers, we gain perspective on the solar system as a dynamic, interconnected family of worlds, each contributing to a story billions of years in the making, and each a reminder of the beauty, danger, and wonder that lies beyond the earthly horizon. The story of the solar system begins over 4.6 billion years ago, in a vast, cold cloud of gas and dust, a stellar nursery where gravity slowly pulled particles together, forming a rotating disk around a newborn protostar, our Sun. From this chaotic, spinning cloud emerged planets, moons, asteroids, and comets, each shaped by gravity, collisions, and the subtle physics of angular momentum. The inner planets, Mercury, Venus, Earth, and Mars, coalesced from heavier, rocky materials, while the outer giants, Jupiter, Saturn, Uranus, and Neptune, accreted gas, ice, and volatile compounds, growing massive and reshaping the solar system through their gravitational influence. The process was violent, punctuated by collisions and ejections, yet it resulted in a structured, harmonious system, each planet locked into an orbit that balances the gravitational forces of the Sun and its siblings. Planetary formation was a story of extremes. The inner solar system experienced intense heating, impacts, and differentiation, with dense cores forming metallic interiors and silicate mantles. Volatiles were driven outward by solar radiation, shaping the compositions of terrestrial worlds. The outer regions, colder and more distant, allowed ices to persist, creating gas and ice giants capable of capturing moons, sculpting rings, and influencing smaller bodies in the Kuiper Belt and Oort cloud. Collisions with comets and asteroids delivered water and organics to early Earth, potentially seeding the planet with the ingredients for life. The entire solar system emerged as a delicate balance of chaos and order, a dynamic system governed by fundamental forces, yet full of surprises and complexity. As the solar system evolved, migration of planets played a crucial role. Jupiter and Saturn, in particular, may have shifted from their birthplaces, scattering smaller objects, influencing asteroid and comet populations, and perhaps even shaping the conditions for life on Earth. Uranus and Neptune moved outward, capturing and disturbing Kuiper Belt objects, while the inner planets stabilized into the orbits we observe today. The Sun matured, gradually increasing in luminosity, while its solar wind swept away remaining gas and dust, leaving behind a cleaner system of planets, moons, and small bodies. Each element of the solar system, from the blazing sun to the icy fringes of the Kuiper Belt, is a record of these early formative processes, a story written in rock, ice, and plasma. Looking forward, the future of the solar system unfolds over billions of years, driven by the inexorable evolution of the Sun. In roughly 5 billion years, the Sun will exhaust its hydrogen fuel and expand into a red giant, swelling to engulf Mercury, Venus, and potentially Earth, while scorching the inner planets and altering the dynamics of the outer solar system. During this period, the orbits of remaining planets may shift, moons may be ejected or collide, and small bodies may be scattered into new regions of space. Eventually, the sun will shed its outer layers, leaving behind a dense white dwarf, a cooling ember that will illuminate the remaining planets and objects for trillions of years to come. The solar system will continue to evolve, shaped by gravity, radiation, collisions, and the ongoing flow of cosmic energy, even long after the sun has faded. Beyond the fate of the sun, the solar system will continue to interact with the wider galaxy. Passing stars, interstellar clouds, and gravitational perturbations will influence the orbits of distant objects in the Oort cloud and Kuiper belt. Comets may be sent plunging into the inner regions, while distant dwarf planets and icy bodies may be perturbed into new orbits. Even as the inner planets face eventual destruction, the outer reaches will remain a record of the solar system's history, preserving the evidence of formation, migration, and cosmic evolution. These small bodies are time capsules, containing the story of the sun's birth, the creation of planets, and the subtle interactions that define the architecture of a star system over billions of years. The story of the solar system is also a story of humanity. For millennia, we have gazed at the sun, moon, planets, and stars, building myths, measuring time, and seeking understanding. With telescopes, spacecraft, and probes, we have explored each planet, flown past moons, landed on asteroids, and even glimpsed the outermost fringes of the Kuiper belt. Through missions like Voyager, Cassini, New Horizons, and Parker Solar Probe, we have transformed distant points of light into worlds with mountains, storms, rings, and oceans, revealing a solar system more complex and beautiful than our ancestors ever imagined. Each discovery enriches our knowledge, reminding us that we are part of this cosmic story, intimately connected to the sun and planets through gravity, light, and the passage of time. In contemplating the formation and future of the solar system, we confront both the power and fragility of cosmic forces. We see the immense energy of stars shaping worlds, the slow but inexorable evolution of planets, and the delicate conditions required for life to emerge. We realize that our existence on Earth is a fleeting moment in a vast, dynamic system, and that the solar system, with its planets, moons, rings, and small bodies, is a living laboratory for understanding the universe itself. As we continue to explore, study, and dream, the solar system invites us to witness the beauty of creation, the passage of time, and the unfolding of a story billions of years in the making. A story in which we are observers, participants, and chroniclers of the cosmos. The solar system, from the blazing heart of the sun to the icy edges of the Kuiper belt and beyond, is a testament to the forces that shape the universe: gravity, motion, energy, and time. It is a system of harmony and chaos, extremes and balance, destruction and creation. Each planet, moon, asteroid, and comet is a chapter in this epic, and together they tell a story that spans billions of years, a story of formation, evolution, and the inexorable march toward the future. In understanding this story, we come to understand our place in the cosmos, the fragility and resilience of life, and the awe-inspiring complexity of the universe we call home. As we journey through the solar system, from the blazing heart of the sun to the frozen edges of the Kuiper belt and beyond, we are reminded of the immense scale, complexity, and beauty of the cosmos. Each planet, moon, asteroid, and comet tells a story of formation, collision, evolution, and survival. Together, they weave an intricate tapestry, revealing the forces that shaped our solar system and continue to govern it billions of years later. This final chapter is not merely a summary, but a reflection on the profound connections between these celestial bodies and the human spirit, our drive to explore, to understand, and to witness the grandeur of the universe. The solar system is a dynamic, living system. It is not frozen in time. It moves, evolves, and interacts. Planets exert gravitational forces on one another. Moons orbit with precision yet subject to subtle tugs, and asteroids and comets traverse paths shaped by billions of years of motion and chance. Storms rage on Jupiter and Neptune. Icy geysers erupt on Enceladus and Triton, and auroras shimmer across planetary poles, painting the cosmos with light and energy. These phenomena remind us that the solar system is not static. It is a dance of physics, chemistry, and time, a stage upon which forces far beyond human comprehension perform endlessly, shaping worlds, sculpting surfaces, and creating conditions both harsh and delicate. As we reflect on the journey, we see the solar system not just as a collection of objects, but as a story of extremes and balance. Inner planets, small and rocky, teach us about resilience, atmosphere, and the conditions necessary for life. Gas and ice giants, massive and mysterious, reveal the power of gravity, energy, and motion on a grand scale. Dwarf planets and icy bodies in the outer reaches preserve the history of the solar system, frozen relics from its formation, whispering secrets about the origins of planets, moons, and perhaps life itself. And the sun, radiant and constant, binds all these worlds in its gravitational embrace, giving energy, light, and life, reminding us that even the most distant planets are shaped by a single central source. Humanity's exploration of the solar system is still in its infancy, yet it has already transformed our understanding. Telescopes, orbiters, landers, and flyby missions have revealed mountains on Mars, geysers on Enceladus, rings around Saturn, and the icy plains of Pluto. Each discovery expands our knowledge and fuels our imagination, bridging the gap between the familiar Earth and the vast unknown. We see that exploration is not merely about observation, but about connection, linking ourselves to the planets, moons, and small bodies in ways that inspire awe, humility, and wonder. The solar system becomes more than a physical space. It becomes a mirror, reflecting our curiosity, ingenuity, and the unyielding desire to know the universe. Looking forward, the solar system will continue to change. The sun will age, planets will drift, moons may collide, and icy bodies will journey through the dark reaches of space. Yet even in change, the system demonstrates resilience and order, showing us that chaos and harmony coexist. By studying the past and present of these worlds, we gain insight into the future, not only of the solar system itself, but of our place within it. We understand that life, including humanity, is a fleeting moment within the vast cosmic dance, yet one capable of curiosity, discovery, and imagination. As we conclude our journey, the solar system stands as a testament to the power, beauty, and complexity of nature. It is a story written in gas, rock, ice, and light, a story that began billions of years ago and will continue for billions more. It is a story of extremes and balance, violence and creation, isolation and connection. And it is a story that humanity is only beginning to read. We leave the planets behind, the moons, rings, comets, and distant icy worlds, carrying with us the lessons of scale, energy, and time. The solar system is both a laboratory and a sanctuary, a place of wonder and discovery, a reminder that the universe is vast, mysterious, and profoundly beautiful. In the silence of space, beyond the reach of sunlight and warmth, the planets continue their eternal motion. Jupiter's storms rage, Saturn's rings shimmer, Uranus rolls on its side, Neptune spins in deep blue, and Pluto drifts in frozen solitude. Asteroids and comets wander between worlds, the sun radiates its golden light, and humanity peers outward, seeking knowledge, understanding, and inspiration. The solar system, in all its majesty, invites us to witness, to explore, and to dream. It is not merely a collection of celestial bodies. It is a cosmic story of creation, evolution, and wonder, and we are privileged to be part of it, observers of a grand narrative that stretches from the blazing core of the sun to the icy frontiers of the universe, a story without end, waiting for each generation to uncover its secrets and marvel at its splendor. In the silence of the cosmos, a single star illuminates a vast, dark expanse. The sun, radiant and eternal, casts its golden light across a family of worlds, each unique, each with its own story. From the scorching surface of Mercury to the frozen plains of Pluto, the solar system is a symphony of motion, energy, and time, a cosmic masterpiece shaped by gravity, collisions, and the delicate balance of forces that govern the universe. Tonight, we embark on a journey unlike any other, traveling across billions of kilometers, through storms, rings, and icy realms to witness the majesty of our celestial neighborhood. This is not just a journey of facts and figures. It is a journey of wonder, of discovery, of connection. Each planet, each moon, each comet and asteroid tells a story of creation, survival, and transformation. We will witness the fiery birth of the sun, the turbulent atmospheres of gas giants, the icy mysteries of distant worlds, and the fragile beauty of planets like Earth. Along the way, we will explore the forces that shaped these worlds, the histories etched into their surfaces, and the dynamic systems that continue to evolve across billions of years. As we begin, let us step beyond the boundaries of Earth, leaving behind the familiar sky, and travel outward. Let us follow the path of planets, moons, and small bodies, through storms, rings, and icy reaches, guided by curiosity, science, and the timeless human desire to know our place in the cosmos. Our journey begins with Mercury, the closest world to the sun, a planet scorched by heat and sculpted by gravity, a window into the forces that shaped the inner solar system. Mercury to Venus. As we leave Mercury, scorched and cratered, we turn to Venus, a planet cloaked in dense clouds of acid and mystery. While Mercury bears the scars of impacts, Venus tells a story of heat, pressure, and runaway greenhouse forces, a planet both hostile and mesmerizing, where volcanoes and atmospheric storms rage beneath thick, golden skies. Venus to Earth. From Venus, extreme environment, we move to Earth, a fragile oasis of life and balance. Here, the story of habitability unfolds, where water, atmosphere, and energy converge to create the conditions for life, and where our own planet becomes a benchmark for understanding the forces shaping all worlds. Earth to Mars. Beyond Earth lies Mars, a planet of red deserts, icy poles, and ancient riverbeds. Its landscape tells a story of water, climate change, and the potential for past life, revealing the delicate interplay of environment, atmosphere, and time that has shaped a world both familiar and alien. Mars to Jupiter. Leaving the rocky worlds behind, we journey to the realm of giants. Jupiter, colossal and majestic, dominates with storms, belts, and a gravitational might that shapes the solar system itself. Its moons, from volcanic Io to icy Europa, add depth to this dynamic world, hinting at hidden oceans and the potential for life beyond Earth. Jupiter to Saturn. From Jupiter's storm-laden clouds, we glide to Saturn, the ringed wonder. Its luminous rings, diverse moons, and swirling atmosphere illustrate the elegance of physics at cosmic scales, reminding us that beauty and complexity can coexist in the dance of gravity and motion. Saturn to Uranus. Beyond Saturn, Uranus tilts sideways, an icy giant rolling along its orbit. Its subtle blue hue belies extreme seasons, winds, and moons that tell a story of collisions, internal energy, and distant mysteries, a world both familiar in composition and alien in behavior. Uranus to Neptune. Next, Neptune waits in deep blue splendor, a planet of supersonic winds, colossal storms, and distant moons. Its great dark spot, raging storms, and magnetic mysteries reveal the power of energy in the far reaches of the solar system, where sunlight is dim, but forces remain immense. Neptune to Pluto and dwarf planets. Far beyond Neptune lies Pluto, the symbol of the solar system's outer frontier. Here, icy plains, nitrogen glaciers, and orbiting moons preserve the story of formation and evolution, reminding us that even at the edges, the solar system is vibrant, diverse, and alive with history. Dwarf planets to small bodies. From Pluto, we explore asteroids, comets, and meteors, the remnants of planetary formation. These small bodies, traveling across space, carry the secrets of billions of years, impact histories, and chemical clues, linking the inner and outer solar system in ways both subtle and profound. Small bodies to the Sun and formation. Finally, we circle back to the Sun, the heart of the solar system. Its energy and gravity bind the planets, moons, and small bodies in a cosmic ballet, while its life cycle reminds us of creation, evolution, and the impermanence of worlds. By understanding the Sun, we understand the forces that shaped the solar system and the potential futures awaiting our planetary family. Our journey through the solar system reveals a story of extremes, balance, and eternal motion. From molten Mercury to distant Pluto, from blazing storms to icy geysers, from rocky craters to luminous rings, the solar system is a living laboratory, a gallery of cosmic wonders, and a testament to the forces that govern the universe. It is a story of creation and evolution, of beauty and danger, and of humanity's relentless quest to understand its place in the cosmos. As we look up at the night sky, we see more than points of light. We see the echoes of collisions, the dance of gravity, the energy of stars, and the frozen remnants of ancient worlds. Each planet, moon, and small body carries a story billions of years in the making. And as our eyes and minds expand to comprehend these wonders, we realize that the solar system is not merely a collection of objects, but a living, dynamic family of worlds, a cosmic story in which we are observers, explorers, and storytellers. The journey may end here for now, but the solar system continues its eternal dance, spinning, orbiting, and evolving, inviting future generations to explore, to question, and to marvel at the vastness and beauty of the cosmos. And in witnessing this grand narrative, we come to understand our own story, fragile, fleeting, and yet profoundly connected to the celestial wonders that surround us. Thanks for drifting with me through our peaceful solar neighborhood. We explored how the sun, planets, and distant icy worlds all share a quiet, orderly orbit that keeps our cosmic home beautifully balanced. If you enjoyed this gentle journey, please like, subscribe, and comment with the next soothing topic you'd love to explore. And if you're still awake, watch another sleepy science facts video and keep drifting through the stars. Rest easy, traveler of the cosmos.